Assalamualaikum and hi, my name is Nawal binti Muhammad Radi. So today my lab partner and I will be presenting lab 2, which is Introduction to Programmable Logic Controller. So let's move to the lab activity 1, which is latching. So in this lab activity, we need to develop the ladder diagram in the figure 1 in a logo and transfer the program to PLC and run the program. So based on the ladder diagram, we have push button 1, push button 2, internal relay, and fan as a load. So this is the circuit based on the ladder diagram in the lab sheet for lab activity 1. We have I1 as a push button 1, I2 as a push button 2, I3 as a reset button, and I4. But we will not use I4 in this lab because it is not connected to our circuit. So when we press I1, the current will flow into the circuit, hence it will energize I1 and I2. So as a result, the fan will be turned on. So here we can see that the fan is turned on. And while when we want to turn off the fan will not turn off if we just depress I1, even there is no current flow in I1 anymore. So to turn off the fan, we need to press I2 because I2 is a normally closed contact.
Hello, my name is Sharifah Azila binti Raslan and I will conduct for lab activity 2A. Circuit is connected to turn on and turn off delay, which is turn on delay we set to 5 seconds and turn off delay we set to 10 seconds. When push button number 1 is pushed, bulb will light on and it will light off after 5 seconds, and fan also will turning on. Okay, as you can see, the fan is turning on. Then when we push button number 1 again, the bulb is turning on while fan still also turning on, and the fan is turning off after 10 seconds as per set in the turn off delay.
In lab activity task 2B, we also need to develop the ladder diagram, but we need to set the on delay timer to 5 seconds and transfer the program to PLC and run the program. So based on the ladder diagram, we have push button 1, push button 2, timer on delay, and lamp, fan, and buzzer as the loads. In task 2B, the lamp will turn on immediately when we press I1, which is push button 1, while the buzzer and the fan will be turned on after 5 seconds the I1 is being pressed. While when we depress I1, the lamp, buzzer, and the fan will turn off immediately. So this is the ladder diagram for task 2B. We already connected the lamp, which is Q1, to the output timer on delay. Hence, the lamp will turn on immediately while the buzzer and the fan, which is Q2 and the Q3, is connected to an input timer on delay. So it will turn on after 5 seconds, the push button 1 being pressed.
So let's move to task number 3. So as you can see, IR or PB1 is connected to a reset pin in counter, and I2 or PB2 is connected to counter pin, and I3 or PB3 is connected to the IR pin. Then counter up down counter is connected to buzzer. The counter is set to 5 times. Then when we push button number 2, which is I2, for about 5 times, the buzzer will produce the sound. To turn off the buzzer, press push button number 1 to reset.
For observation for this lab activity, the first question is state the IP address, subnet mask, and gateway for your PLC unit. So for our PLC unit, the IP address is 192.168.000.001, while the subnet mask is 255.255.255.0, and the gateway is 192.168.0.0. For the second question, state the actual numbers of input and output available at the Siemens logo PLC base unit. So there are 4 number of input and 3 number of output in the Siemens logo PLC base unit. Next, for question number 3, state the address of the input switches. The address of the input switches we use in this lab is I1, I2, I3, and I4. And question number 4, state the address of the output lamp, buzzer, and fan. The address of the output lamp is Q1, buzzer is Q2, and fan is Q3. So for the next question, which is question 5, 6, 7, 8, will be answered by Zila.
Okay, question number 5. How to reset the timer in lab activity task 2B? To reset the timer in task 2B, we have to press the push button 1 because PB1 is connected to the reset pin of the counter. Then number 6 is how do you set the counter to count up and count down in lab activity 2? To set the counter to count up and down is by pressing the PB3 as PB3 is connected to the IR pin of the counter, and explain what happened to the output buzzer when the counter counts up more than 5. The buzzer will still produce the sound. And the last one is explain what happened to the output buzzer when the counter counts down less than 5. The buzzer will not produce the sound because the counter has not reached 5 times, pushing the push button number 2.
For question number 1, discuss the importance of latching in ladder diagram and describe an actual application that implements latching. So the output latch instruction is a retentive output instruction that is used to maintain or latch an output. So if this output is turned on, it will stay on even if the status of the output logic that caused the output to energize become false. For example, such a situation is a motor which is started by pressing a button switch. Although the switch contact do not remain closed, it is required that the motor continue to run until a stop button switch is pressed. The latching used to stay the motor run until the push button is pressed again. So typically latches are used to keep the condition of the bits to encode binary numbers. Latches are a single bit storage element which are widely used in computing as well as a data storage. And latches are also used in the circuit like power gating and clock as a storage device. For the second question, explain what happens when the inputs are connected in parallel. The input will be functioning as there are 2 inputs control the output by latching. So the next question, which is question number 3 and number 4, will be continued by Zila.
Okay, for the question number 2, explain what happened when the inputs are connected in parallel. The input will be functioning as there are 2 inputs control the output by latching. Question number 3, explain what happened when the outputs are connected in parallel. Input still function because the 2 input control the output. Okay, and then discuss the importance of PLC industrial application. First, it's easy to troubleshoot and operate, robust and rugged, and cost effective. That's all from us. Thank you.